Okay, in this session, we are going to cover geometry. So let's start with some basic concepts. This is a point A, this is a point B. And when you join the 2 points, it's a line segment, and the distance between A and B is called the length. So this is what we call one dimension. For example, you have a pencil and you measure the length of the pencil. This could be 6 inches. Okay, so that's called one dimension. So now look at this picture here. So this is 2 dimension. We've got the length, we've got the width. So if you have a piece of paper, the paper, you can measure the length, you can measure the width. Okay, so that's called 2 dimensions, 2-dimensional object, or 2 dimensions. And look at here, this is a box. This box has got the length, it has got the width, and I've got the height. And this is called 3-dimensional box. Okay, so this is the concept of dimensions. So let's just do an example, 1-dimensional example. So let's say Tom needs a hose that's 96 feet long in order to water his lawn. The length of the hose that's available is only 32 feet long. How many hoses does he need? So this is a familiar problem for you. So we've got 96 feet total, and then we've got 32 feet each hose. 96 divided by 32, you've got 3 hoses, right? You've got 1 hose, 2 hose, 3 hose. That'll cover the 96 feet, okay? So that's just a 1-dimensional problem, okay? So let's look at a 2-dimensional example or 2-dimensional problem. Here I've got a tile. This tile is a square tile, and every side is exactly 1 foot long. And the area of this tile is defined as exactly 1 square foot, okay? So now let's say that I have a foyer and it's a rectangle, 3 feet by 2 feet rectangle. How many tiles do I need? So I can lay out exactly 3 tiles this way, another 3 tiles this way. So I can cover my foyer with exactly 6 tiles. So the area of my foyer is 6 square feet because every tile is 1 square foot. I have exactly 6 tiles. So the area is 6 square feet, okay? Now the rectangle, if we want to write a formula for the area for this rectangle, we can write 3 times 2 is 6 square feet. So now you know why 3 times 2, because we have 3 times 2, that many number of tiles. Each tile is 1 square foot, okay? So we can write down the formula for rectangle, length times the width is the area, okay? And this is the reason. So this is another example. So let's say I've got the same square tile, and in every side is exactly 1 foot, okay? So I have actually a foyer which is a square. I've got 6 feet by 6 feet square, okay? So then I can lay out 6 tiles, 6 tiles, 6 tiles, like that, 6 rows. So totally I can cover my foyer with exactly 36 tiles. So the area of my foyer is exactly 36 square feet because each tile is exactly 1 square foot, okay? So now I can write down the formula. The area of the square is exactly, each side is 6 feet. I can write it as 6 times 6, which is 36. So the reason is because, I can cover this area with 36 tiles. So now you know why the area of a square is side times a side, right? So now let's go to a 3-dimensional example. Now I've got a little cube here, this blue cube, and the length is 1 inch, width is 1 inch, and the height is 1 inch. And this volume of this cube, how the capacity of this cube, or the volume of this cube, or if it is a hollow cube, if I have to pour water, how much can it hold, right? And that's defined as 1 cubic inch, okay? So now let's look at this big, the red cube, and this has got exactly 2 inches length, 2 inches width, and 2 inches height, okay? So now, how many of these blue cubes I can put in here? So the blue cubes 1 by 1 by 1. So I actually, in the front half of this red cube, I can put 1, 2, 3, 4, right? I can, if the red cube is hollow, I can fill the front half with 4 blue cubes. the back half with another 4 cubes, right? So 4 and 4, exactly 8 blue cubes will go into that, okay? So now the volume of this red cube is exactly 8 cubic inches. Why? Because I have 8 blue cubes that fill in the red cube, and each blue cube is exactly 1 cubic inch. Okay, so with 8 blue cubes, I've got 8 cubic inches. Okay, so now we can actually write down the formula. The volume or the capacity of this red cube is 2 times 2 times 2 if the length, width, and the height are exactly 2 inches. Now you know why 8, because I can put in 8 1-inch cube inside that, right? So now you need to be careful with the units. So let's say that I still have this 1 cubic inch, I've got the blue cube. Then I have this big black cube, and the black cube, every side is exactly 1 foot, okay? So now 1 foot, this is 1 foot, and this is 1 inch. So what you have to do is, if you want to find the volume of this, the black box in terms of cubic inches, you need to convert this 1 foot to 12 inches, right? So the length is 12 inches, width is 12 inches, height is 12 inches. So how many of these blue cubes I can put in here? So because this is exactly 12 inches, I can put 12 these blue cubes here, another 12, another 12, another 12. I can put stack 12 this way, 12 that way, so that I have 144 blue cubes right in the front. And then behind that, another 144. Behind that, another 144. I can keep going because this is 12 inches and each cube is only 1 inch. So I can go that way, 12, right? So just by the, similar to the previous argument we had in the previous slide, how many blue cubes I have here? 12 times 12 times 2, 1,728 cubic inches. That is the volume, right? Because each blue cube is 1 cubic inch. So now, so the formula for the volume of this cube is just like before. Here I've got 12 inch, 12 inch, 12 inch. So 12 times 12 times 12, that is 1,728 cubic inches. Now you know exactly why. So now, when you have these 3-dimensional shapes, you can actually calculate the area also, the surface area. For example, in this little blue cube, I have how many faces I have? I have got the front face, back face. On the left-hand side face, right-hand side face, top face, the bottom face. There are 6 sides or 6 faces, right? And each face, if you take the front face, it's a 1 inch by 1 inch square. So the area is 1 square inch, right? And the top is 1 square inch. Side is 1 square inch. And the other side is 1 square inch. Bottom is 1 square inch. Back is 1 square inch, right? So the total surface area of this blue cube is exactly 6 square inches because we've got 6 faces. Each face is exactly 1 square inch, right? So now let's go to the red cube. If you take the red cube, you can exactly define, you can divide, this face into 4 equal squares, right? So since I've got 2 inches, 2 inches, 2 inches, so then I've got, this is 1 inch, 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 right? I've got exactly 4 squares here. So this area, so because this is 2 inch, 2 times 2, this area exactly 4 square inches, right? And I have exactly 6 faces. Each one is exactly 4 square inches. So the total surface area of the red cube is 6 times 4, which is 24 square inches. Okay? So now let's go into a different concept, angles. So we talked about points and lines. So let's start here. So I've got, I've got 2 red points here. I've got a line through that point. I've got another line through this point. So I've got 2 intersecting lines. Okay. When I have 2 intersecting lines, so in this case, for example, it's exactly like an L. Okay. So when they meet like this, so then that angle, when it's exactly like a straight down, straight across, that angle is exactly, we measure that as 90 degrees. So that angle is defined as 90 degrees, okay? But if the two lines kind of squished like this, and then the angle is less than 90 degrees, then we call that angle as acute angle, okay? On the other hand, if these two lines open up like this, okay, so then this is more than 90 degrees, then we call that obtuse angle. When then these two lines open up completely, so then it becomes a straight line, so then that angle is called straight angle or 180 degrees, okay? So now let's look at this picture. So now I've got this L shape, so that means that I've got 90 degrees. Let's say another line, here at the passing through this point here. So now I've got two angles here, right? And I know that the totally this is 90 degrees, right? Like an L 90 degrees. But I've got 60 and 30, so these two angles should always add up to 90 degrees, right? So we call these two angles are complementary to each other. So 30 degrees is complement of 60, 60 degrees is complement of 30, right? So 60 is 90 minus 30. Similarly, 30 is 90 minus 60, right? So these are called complementary angles. And then when you have a straight angle, so another line passing through this point here, and we know that the straight angle is 180. So if I know one angle, if this angle is 135, then I know what the other angle is. It's always going to be 180 minus 135. It's 45 degrees, right? Because these two angles always add up to 180 degrees, and these are called supplementary angles. So if I know one angle, I can calculate the other angle, which is 180 minus that, okay? Okay, so now we talked about the x-axis, y-axis before. So x-axis, y-axis, when they meet at the origin, exactly, it is like an L shape, right? So the first quadrant, so that's 90 degrees. Second quadrant, another 90 degrees. Third quadrant, another 90 degrees. Fourth quadrant, another 90 degrees. So on the positive x-axis, if I start, and then if I start move around, come back to the x-axis here, then I would have traveled 360 degrees angle, right? So let's look at another example here. So this clock is showing exactly 6 o'clock, and this red arrow is the minute hand, okay? So then when the minute hand moves, if after 15 minutes, it would have done exactly, it would have traveled 90 degrees. And then another 15 minutes, another 90 degrees. Another 15 minutes, another 90 degrees. Another 15 minutes, another 90 degrees. So from the time when it goes from 6 o'clock to 7 o'clock, then the minute hand would have traveled 360 degrees angle, right? So every 15 minutes it does 90 degrees, and half hour it makes 180 degrees, 1 hour it makes exactly 360 degrees, okay? Okay, so if the two lines don't exactly cut a 90 degrees, so they can cut anywhere, just like an X. You've got two intersecting lines like an X. So in that case, it's not exactly 90 degrees. So then we call this blue and then the blue, they are called the opposite angles. Sometimes we call them vertical angles. And the vertical angles of the opposite angles always equal, like a 134. The blue is exactly equal to this 134. So the opposite of the vertical angles will always be equal. Then the other two vertical angles are exactly here, 46 and 46. Other two vertical angles will be exactly equal. And then because this is a straight line, 134 plus 46, that always it has to be 180 degrees, okay? So if I know one vertical angle 134, I can always find the other vertical angle because it's going to be 180 minus 134, okay? So now let's say that I've got two parallel lines. So I've got the CD, AB, two parallel lines. So what do I mean by parallel lines? If you look at the train tracks, so these two train tracks, they never meet, right? They keep going, going, going. They will never ever meet. So the two lines which they never meet are called parallel lines, okay? So now there is a transversal, so another line that is actually cutting the two parallel lines, okay? So then we know that these two vertical angles A and G are equal, and then these two vertical angles H and B are equal. Similarly here, D and F two vertical angles are equal, E and C two vertical angles are equal. But then now when you have these two parallel lines and transversal, this angle G is exactly equal to angle C. These are called corresponding angles. They are always equal. Similarly, this angle B is equal to angle F always. Similarly, this angle H is equal to angle D. Similarly, angle A is exactly equal to angle E. Okay? So this is an interesting property that you need to remember. So now we are going to talk about some two-dimensional shapes. Okay? So let's start with the triangle. So what do we mean by a triangle? Triangle means that there are actually three sides. So we've got a shape, we've got a figure, we've got a shape. It's got actually three lines. Okay, three lines. And then three angles. Triangle means three angle. So you actually see that you've got three angles like that, right? So this triangle here, where the sides, each side is different length, it's called a scalene triangle, acute scalene triangle, because all the three angles are acute angles, right, less than 90. And scalene means that all the three sides are different lengths, okay? Equilateral triangle means that, like you can see here, all the three sides are exactly equal, okay? And then one important property you need to remember for the triangle, sum of all the three angles equal to exactly 180 degrees, okay? So the equilateral triangle, because all the three add up to 180, then each angle has to be exactly 60. All the three angles are equal, so each one is 60. All the three sides are equal. That's called equilateral triangle, okay? Isosceles triangle means that two sides are equal and then the opposite two angles are also equal, okay? Obtuse scalene triangle means that one angle is actually obtuse angle, more than 90 degrees, and then all the three sides are not equal. That's called obtuse scalene. Right triangle means that one angle like this, you got like an L, right? And so that is exactly 90 degrees. That's called a right triangle. Isosceles right triangle means that I've got a right triangle, but then the two sides are exactly equal. So the two opposite angles are going to be equal. So then since all the three angles need to add up to 180 degrees, this is 90 degrees, the other two are 45, if it's an isosceles triangle, okay? Isosceles right triangle. And then if you have any triangle on the bottom, we call it the length of this, in the bottom part of the triangle, we call that B, the base. And then from the opposite point, opposite vertex, you exactly draw a straight line. Straight line means what? Exactly like a flagpole. You know, it's just straight sitting on the ground. So that means that when you draw the line, that means that this is exactly 90 degrees, and that's called the height, H. Anytime we say height, it's exactly, it's like a straight down, so it is actually making 90 degrees with the base. That's what that means. Then when you have a right triangle like this, and then these two sides are called the legs, and the longest side of the right triangle is called the hypotenuse. So the longest side is always opposite to this 90 degrees, okay? So the side opposite to 90 degrees is always the longest side, and it's called the hypotenuse, okay? So now a Pythagoras theorem, so this is when you have a right triangle, for example here, I've got a side A, that's one leg, side B, other leg, C is the hypotenuse. So then the Pythagoras theorem says that A squared plus B squared equal to C squared, okay? So let's look at the example why you know that is true. So let's look at the example here. I've got a right triangle. The base, this leg is exactly 3 feet. The height here, this leg is exactly 4 feet. And the hypotenuse is exactly 5 feet, okay? So that right triangle, that triangle, I put it here. So B is exactly 3. This A is exactly 4. This C is exactly 5, okay? So now when we say A squared, Okay, so when we say a squared, what exactly do we mean? So here it's this a is 4 feet. So we saw before 4 squared means what? So that means that I have a square. 4 times 4 is 16, right? So I have a square. So this each one is like a 1 foot tile. So I have 4 times 4, 16 tiles here. So when I say 4 squared, that means 16. That also means that I've got a square and it is filled with exactly 16 tiles, right? That's what that means, because I have a square with side 4. So here I have a square with side 3, exactly 3 feet. So that means that I can put 3 tiles, 3 tiles, 3 tiles. So b squared is exactly going to be, we can call it b squared is 9. We can also see that the b squared is exactly 9 tiles, okay? So similarly, the hypotenuse here is exactly 5 feet. So you got exactly the squared, c squared is exactly 25, which means that I've got exactly 5 times 5, 25 tiles here, right? So now you can see that if you add the 16 tiles plus this 9 tiles, 16 plus 9, I get exactly 25 tiles, right? 16 plus 9 is 25. So now you know why the Pythagoras theorem is true, right? Okay, so now let's do some Pythagoras theorem applications. So let's say that I've got a right triangle and this leg is 6, this leg is 7. I want to find the hypotenuse. So all you have to do is do the 7 squared plus 6 squared and then take the square root and 9.22. So that is the length of the hypotenuse, okay? And then in this triangle, I have the hypotenuse is 18, one leg is 6, and we want to find the other leg, okay? So in this case, you would take the 18 squared, which is hypotenuse squared, minus 6 squared, okay, and then take the square root of that. So that's going to give me this leg, which is 16.97, okay? And then here, this one leg is 8, and then this hypotenuse 24. Now we want to find this leg, okay? So this leg is square root of 24 squared minus 8 squared, right? So that is, and then you take the square root of 24 squared minus 8 squared. If you do it in the calculator, that's coming out to be 22.63. So the base of this length is exactly 22.63 units, okay? So let's do another problem on the bottom here. If a ladder is placed 4 away from the base of the wall, and if it is a 12-foot ladder, how far up the wall the ladder will reach? So this is the wall here. Ladder is exactly 12 feet here. And from the wall, it's 4 feet away from the wall. Now we want to find this distance here, right? So using Pythagoras theorem, it's all plug in, right? So this side is square root of 12 squared minus 4 squared. So that you can do in the calculator. So that's exactly 11.3 feet, okay? So now, so the triangle was a 3-sided shape or figure. Now we are going to 4-sided figures or 4-sided shapes, and they are also called 4-sided polygons. They are also called quadrilaterals, okay? So they all mean the same thing. And just like the way in triangle, the 3 angles add up to 180 degrees, in the quadrilaterals, the 4 interior angles will always add up to 360 degrees, okay? So this is a rectangle. So, okay, so all the angles are 90 degrees. These 2 sides are equal. The 2 lengths are equal, 2 widths are equal. And this is a square. All the 4 angles are 90 degrees. All 4 sides are equal. Parallelogram means these 2 opposite sides are parallel, equal, and these 2 opposite sides are equal and parallel, okay? Trapezoid means that only these 2 sides are parallel, the other 2 sides are not parallel, okay? Rhombus means that these 2 sides, opposite sides are parallel and equal, and these 2 opposite sides are parallel and equal, okay? So these are all the different names and shapes of quadrilaterals. So in all these problems, all the polygons we are interested in two things, perimeter and area. So what do we mean by perimeter? So let's say we've got the square here. So let's say this is like a square fence. So if you walk around the fence, let's say you start here, walk this side, walk that side, walk that side, walk that side. You go around and come back once, and that's called the perimeter. So that tells you how many feet you have walked around. You are walking around once. That's perimeter. Area means that, if I want to paint this, what is the area? Okay, so that's, so in all these shapes, there will be formulas for calculating the perimeter and also the area. So in the square, perimeter is, if the side of the square is exactly S, perimeter is 4 times S, right? S plus S plus S plus S, 4S. Area is S squared. We already saw that using the tile example, right? So if S is exactly 5 feet, we want to find the perimeter, all you have to do is plug in. The only thing you need to remember in all these formulas is plug in. That's the only thing. So 4 times 5, 20 feet. So if you walk around this once, you would have walked around 20 feet. Area, 5 times 5 is 25 square feet. Okay, so you know why? Because we already went through the tile example. Rectangle, and this is called the length, this is called the width. Okay, perimeter, if I walk around once around this rectangle, it's 2 times L plus 2 times W. That's a perimeter. Area is length times the width, which we already saw using the tile example. So if length is 6 feet and the width is 4 feet, then the perimeter, you just plug in 2L plus 2W, 2 times 6 plus 2 times 4. That's it. Okay, 20 feet. Area is plug in, L is 6, W is 4, 6 times 4, 24 square feet. Okay. So now the other quadrilaterals, for example, parallelogram, and parallelogram, this is called the base. Okay, so this base and this the top, those will be exactly equal. This is called the slanting side S. Okay, so this is S, this is also S. And then I told you the height is always, you need to drop a perpendicular, right? You need to straight down, you draw the line, which is different from the slanting side. Okay. And the height is called H. That's called the altitude. That's H. Okay, that's straight down. It's not slanting. So the perimeter, again, it's 2 times base plus 2 times the S, because you walk around, right? The area of a parallelogram, base times height. Okay, so you just need to look at the formula, answer the questions by plugging in. So if the base is 10 inches, slanting side is 8 inches, height is 6 inches, perimeter is 2 times 10 plus 2 times 8, 36 inches. Area is, the base is 10, height is 6, 10 times 6, 60 square inches. That's it. You just plug in. For this trapezoid, the perimeter, you just need to add all the 4 sides. And then the area of a trapezoid, the formula is 1/2 times H, which is the height, times B1 plus B2, sum of the 2 bases. That's a formula. Okay. So B1 is 9 feet, B2 is 7 feet, height H is 6 feet. So what is the area? Area is, plug in 1/2 instead of H. H is exactly, H is 6, right? That's 6. And then B1 plus B2. So B1 plus B2 is exactly 16. 9 plus 7, 16. And then you put 6, so that's 48 square feet. Okay. So the triangle, the perimeter is, you just need to add the 3 sides of the triangle. That's it. The area of a triangle is 1/2 base times the height. Okay. 1/2 base times the height. So let's say the base is exactly 5 meters. Height H is exactly 8 meters. Then what is the area of the triangle? It's 1/2 times 5 times 8. Okay, so that's exactly 20 square meters. Okay, so these problems are very, very simple. Okay, so now let's do a problem with a different shape. So let's say that David's backyard is a rectangle of 10 meters by 8 meters. So this big rectangle. A triangular portion of the backyard needs to be fenced. So there's a big tree here. So he wants to fence, this area here, this triangular part. The remaining backyard, the shaded portion here, that needs to be sodded. And what is this area? So he needs to decide how many square feet of sod he has to get, square meters, right? So in this, you want to find this area of the shape here. And what you have to do in all these problems is, this kind of shape, we don't know what the formula. We know for, rectangles, triangles, we know the area. So you always need to think through the problem. So if I know how to calculate the area of this whole big rectangle, right? So you can calculate L times W, that is 10 times 80 square meters. You all know that. Then this little triangle area that you don't want, you know the area of that, right? Area of a triangle, half times base times height. So 1/2 base is exactly 3 meters. Height, because this is a rectangle, this is 8, right? So the height is exactly 8. Okay, so 1/2 times 3 times 8, that is 12. So the shaded area is 80 minus 12. So you know how to calculate the area of the rectangle. You know how to calculate the area of the triangle. Take the difference between the two. That is the answer, right? Okay. Let's do another example. So here, Becky's backyard is a rectangle. It's a 20 feet by 15 feet rectangle. Okay. And then the middle, she's got a rectangular swimming pool, 14 feet by 9 feet. Okay. So what is the remaining area? This white area here, what is that area? Okay. So the area of this big rectangle, you know what it is, 20 times 15, right? L times the width, length times the width, 300. And then this swimming pool, area of the swimming pool is again length times the width, 14 times the 9, right? 14 times 9, 126. Take the difference between the two, 174 square feet, that is that leftover area, okay? Okay, so now we are moving on from polygons to a circle. Okay, when you have a circle, so a circle and right in the middle, you've got the center. Okay, from the center of the circle, if you just walk to the circle like that, if you keep walking, so look at this picture here, from the center I'm walking, from center I'm walking, center I'm walking, you see that the distance between the center and any point on the circle like that, it's exactly the same, and that is called the radius. Okay, radius means that the distance between the center and any point on the circle is exactly the same. All these radius are exactly the same. And then the diameter means that it is a line from one point on the circle to another point on the circle, but passing through the center. That's very important. So if I start up here and then through the center, I'm coming all the way down. That's one diameter, okay? Now, you notice that one diameter, if I take one diameter, that's equal to exactly 2 radius. This radius plus this radius together, r plus r, that's my diameter, right? Like that. So then I have a line here. It's also going from one point of the circle to another point of the circle, but it is not passing through the center, so that's called the chord, okay? So don't need to worry about the chord. You need to know what the center is. You need to know what the radius is. You need to know what the diameter is. So this is just the circular kind of patio. You can actually see that when you walk from here to here, here to here, here to here. So these diameters are exactly the same. The radius are exactly the same. You can see that. So now, the diameter, as I said before, the diameter is exactly 2 times the radius, right? So this is one radius, this is another radius, exactly 2r, okay? And then here, instead of calling perimeter, we call it circumference. Circumference means that, let's say, I start at this point, and then I walk around the circle once, and that's called the circumference. And the formula for that is either it's pi d, or 2 pi r, okay, where pi is exactly 3.14, okay? So circumference is same as the perimeter. If I go around once, if I walk around once, how much distance I would have traveled, that is the circumference, okay? And then the area of the circle is pi r squared, okay? So let's do a couple examples. So this circle on the left-hand side, the radius is exactly 4 centimeter, okay? So then we need to find the circumference and the area of the circle. Radius is 4 centimeter means that the diameter is exactly 8 centimeter, 2 times the radius, right? And then the circumference is pi times d. Pi is 3.14. Plug in. D equals 8. You just need to plug in for pi and d. That's it. And then similarly, the area is pi r squared. So you just plug in. Pi is 3.14. R squared means r is the radius 4. 4 times 4. 3.14, 4 times 4. That's it. Okay. Then you can use the calculator. So in this circle, the diameter is given as 10 inches. Okay. So then again, you need to calculate the circumference and the area. So when the diameter is 10 inches, you know that the radius is exactly half of that 5 inches. Okay. So then the circumference is, you can use pi d. Pi is 3.14. Plug in. D is exactly 10. Okay. Area is pi r squared. Pi is 3.14. R squared is 5 times 5. And then you can use the calculator. Okay. So these problems are very, very simple. You just plug in. Okay. So area for different shapes. So let's say the blue circle represents the fountain, and the fountain, its radius is 8 feet. And there is a pathway around the fountain. It's a circle. Okay. And then that circle, the big circle, it says that 12 feet. So this big circle radius is 12 feet. This fountain, little blue circle radius is exactly 8 feet. The pathway need to be sodded. Okay. So how many square feet of sod is needed? So the pathway, again, you know how to calculate the area of the big circle. Okay. Pi r squared. Pi times 12 squared. Pi times 12 times 12. That's it. Right. And then area of the blue circle, pi r squared, pi times 8 times 8. So take the difference between the two, and that is going to be the area of this pathway. That's it. Okay? Okay. Now we are moving ahead with the three-dimensional figures. Okay? Here we've got a rectangular prism. It's a cube. Okay, the cube we talked about before. We talked about the little blue cube and red cube. So here the length is s, the width is s, the height is s. Okay, then we saw before the volume of this cube. We already saw that s times s times s, s cubed. Okay, and the surface area, we already saw that the surface area, there are 6 faces, and each area is exactly s times s, s squared. So the surface area is 6s squared. Okay. So now, if the this cube, if the length of the side is exactly 5 feet, then what is the volume of this cube? It is 5 times 5 times 5, exactly 125 cubic feet. That's the volume of this cube. So we already know why, right? 125, the blue cubes will fit in here. Surface area, we've got 6 faces, 6 times 5 times 5, 150 square feet. You just plug in, right? Plug in the values in the formula. Now we have a rectangular prism box. The length is L, width is W, height is H. The volume we saw, the volume is length times the width times the height. Okay? And the surface area, so it's like we've got a 6 faces. So 2 times LW, that's this, the bottom face and the top face is LW. 2WH, so that means that WH is this side, right side, left side, that's that area. 2 times LH, LH means the front face and the back face, right? So that's the formula for the surface area. So now if the length is 8 meters, width is 4 meters, height is 6 meters, then what is the volume of this box? So it is 8 times 4 times 6, so 192 cubic meters. Surface area, you just need to plug in the numbers. L is 8, and then W is 4, H is 6. Plug in the values here in the formula, you get 208. Okay? So now this is a cylinder, so this means that it's like a soup can, right? So it's like a circular thing. It's a soup can with a Coke can, and the height is the it's called h, okay, and then the radius of the circle is r. Then the volume of the cylinder, you know, how much Coke or how much soup is there, that is determined by this formula pi r squared h, okay. And then the surface area, so the surface area is 2 pi r squared. So pi r squared, we know that's the area. So the top lid and then the bottom part, so that is 2 pi r squared. The side part is actually 2 pi r h, right? So it's the top, the lid, the bottom, and then on the side. So you need to add up all those three areas for the surface area. So let's say that in the cylinder, the height is 6 feet and the radius is 3 feet. Then the volume of this box, you just plug in the numbers here. Pi is 3.14. R squared is exactly 3 times 3. H is 6. And then use the calculator to multiply. Okay. Then the surface area, again plug in. Here, 2 times pi, 3.14, r squared is 9. Okay. And then plus 2 times pi is 3.14. R is 3. And then H is 6. Plug in. And then use the calculator, okay? So now I've got a sphere. That means it's like a ball. I have a ball, okay? That's sphere. And the radius is exactly r, you know, for the sphere. So the volume of the sphere, how much, you know, water I can pour, you know, inside the ball, it is 4/3 pi r cubed. That's a formula. And then the surface area, if I want to paint this ball, the surface area is exactly 4 pi r squared. So let's say I've got a ball with 3 centimeter radius. Then the volume of the sphere is 4/3 and then pi, which is 3.14. R cubed means 3 times 3 times 3. Okay, 36 pi. Sometimes in the answer, they will leave it as a pi, like a 36 pi. Sometimes you can actually, you can plug in pi is 3.14 and then using the calculator you can actually calculate it, okay? Surface area 4 pi r squared, 4 pi 3.14 r squared 3 times 3. That's it, okay? So these problems are very, very simple. So this is a cone. Cone means that it's like a cone ice cream, cone. And on the bottom I've got a circle and I've got a cone. Then this radius is r, the slant height is s, and then the straight height, straight down, that height is h. So then the volume of this cone is 1/3 pi r squared h, okay? And then the surface area of this cone, okay, pi r s. So that's the slanting area, that area is pi r s. The bottom part of the cone, so the lid, the bottom part, that's pi r squared, okay? So let's say that we've got a cone. The slant height is 6 centimeter. The straight height h is 4 centimeter. Radius r is 3 centimeter. What is the volume of this cone? Plug in 1/3. Pi is 3.14. Then r squared, that means 3 times 3. Then h is exactly 4. Just plug in all the numbers. That's it. So then you can do it in terms of pi, 12 pi, or you can plug in 3.14 for pi and then calculate it. And then surface area, pi rs, pi, and then r is 3, s is 6, okay, plus pi r squared, pi, 3.14, r squared, 3 times 3. So then you add up these two together, and then 18 pi plus 9 pi, 27 pi. So it's better to use pi and then simplify. You get 27 pi, and then now you plug in for pi 3.14. If the answer is given in decimals, then you need to plug in 3.14 for pi, and then you will get the answer in decimal. Okay. So now this is a pyramid with a square base, okay? The square base, this square has got a side B, the slanting side is S, straight height is H. So the volume of this pyramid, 1/3 B times H, where B is the bottom base area. Base area. It's not this little b. There's a big B, right? Base area. Then the surface area is 1/2 the perimeter P times S. So P is the perimeter of the base. Like this, add up all the four sides, that's a perimeter. Perimeter times the slanting height S plus the base area, right? The base area is a square, so that's B, so that's a base area, okay? So let's say we've got a cone, the slanting height is exactly 8 inches. The base is a square with 3-inch square, right? Every side is 3 inch. The height is H is exactly 6 inches, okay? So then the volume of this pyramid is 1/3 the base area. What is the base area? It's a square. So 3 inch, 3 times 3, right? 3 times 3. So that's the area of the square times the height, which is exactly 6, okay? 18 cubic inches. Then the surface area, if you use this formula here, it's 1/2 perimeter of the base, 3 plus 3 plus 3 plus 3, right? 12, okay? And then times the slanting height S, which is 8, so that's what you put in here, 8. The bottom, the base area, B is the base area. What is the base area? It's a square. 3 times 3, that's a base area, right? So then you can add them up using your calculator. So now let's do a few example problems. So let's say that this is a swimming pool. How many cubic feet of water is needed for the swimming pool, okay? So the radius of the swimming pool here, that is R, but then the whole diameter is given as 16 feet, okay? Then the height of the swimming pool here, it's 2 feet, okay? So if this diameter is 16 feet, then what is the radius? So you need to know it's exactly half the diameter is the radius, right? So the diameter is 16 feet, the radius is exactly 8 feet. So then the volume of the cylinder, so you need to recognize the shape. This shape is actually a cylinder, circular base is a cylinder. So then in the formula sheet, you can use the formula sheet in the exam, the pi r squared h. Then you plug in pi, r is 8, so 8 squared times height is 2. So then pi times 8 times 8 times 2, so you can use the calculator. Then you can plug in the value of pi, and then you would get in decimal like 401.92 cubic feet. That's how much water you need in order to fill the swimming pool, okay? So let's say that this is a little ball, okay, and this ball radius is exactly 3 centimeter, okay. How many cubic centimeter of liquid is needed to fill this toy ball, okay? So again, you need to recognize the shape first. It is a sphere. If it's a ball, it's a sphere. Then the volume, that's what is needed here. Not the area, volume, because you want to fill in this ball with the liquid, so volume. So then you know that you have to use the volume formula. You can use the formula sheet. So volume is 4/3 pi r cubed. So then pi r the radius is 3. So plug in, instead of r you put 3. What is 3 cubed? 3 times 3 times 3, right? So you use the calculator and then it comes out to be 113.04 cubic centimeter, okay? So now there's a container here. This container has a cylinder at the bottom here and the cone at the top. So what is the volume? So now we've got two shapes. On the bottom, you've got a cylinder. On the top, you have the cone. Okay, we need to find the volume. Okay, so then the volume of the cylinder. Okay, first look at the cylinder and the formula in the formula sheet, pi r squared h. Okay, and then we need to get the volume of this cone here. That is 1/3 pi r squared h. So now here you plug in for this cylinder on the bottom. R is exactly 1 foot. R is 1, right? 1 square is 1. H, height is 3. So pi times 3. And then plus 1/3 pi. And then here R, that R is exactly same as this R, right? So this R is exactly 1. R squared is 1. And then the height of this cone is different. This is 3 feet height of the cylinder, but this is the height of the cone. So height of this cone is exactly 1 foot. So then you plug in r equal to 1, h equal to 1, right? So it's all 1. So all you have is only pi. So then when you simplify and use the calculator, so you can actually use the calculator to convert this fraction to decimal. So then it is 10.47 cubic feet, okay? So then let's do a couple more problems. So let's say that we've got a family room here, and this blue portion is taken away for a closet, and the carpet is needed for the rest of the area. So what is the square feet of the carpet, this area, okay? So again, you need to work with the shapes that you already know. So the big rectangle, 20 feet by 15 feet. So the big rectangle, you know how to calculate the area of that, okay? And then the little rectangle, the blue rectangle, you know how to calculate the area of that. Difference between that is going to give you this carpet area, right? So the big rectangle is 20 times 15, okay? And the area of the closet, that rectangle, 4 times 2, and then take the difference, and that's 292. So that's the area, the square foot of carpet you need is 292 square feet of carpet. That's what you need, okay? So then let's look at this figure here. So we want to find the area of this figure here. So we don't know exactly how to calculate the area of this figure, okay? But you look at here, this whole length is given as 60 feet. This whole width is given as 40 feet, okay? So if this was a complete rectangle like this, then I know how to do this, right? So imagine this full rectangle here, and that area of this big rectangle is 60 times 40. We know that, L times W, right? You do that. And then in the corners, so little corners are cut here. So if you look at that, this is 2 feet by 2 feet. So out of this big rectangle, a little 2 feet square is cut out. Similarly, the same square is cut out here. Similarly, same square cut out here. Similarly, same square is cut out here, right? So the area of this square, you know what it is, right? So this is a square. So side 2 feet. So 2 times 2, 4 square feet is the area of this square. So I've got 4 square feet here, 4 square feet here, 4 square feet here, 4 square feet here is cut out of this big rectangle, okay? So what I have to do is take the area of the big rectangle, which is 60 times 40, minus the cutout area of the 4 squares, 4 times 2 times 2, okay? So that's 16. So they take the difference, and that is 2,384 square feet. So that's the area of this figure, okay? So you always need to think, you know, if they have given you a figure which is not a standard kind of shape, there must be some kind of trick. So you need to figure out the whole rectangle, and then the corners are squares. How do I do that? Similarly here, big rectangle minus little rectangle. Like that, you need to understand and then apply the formula, you know, just plug in. And in the exam, you can actually use the formula sheet, so you don't need to memorize any of these formulas, okay? Okay, in this session, we are going to do some practice problems for Step 5 Geometry, okay? So you can follow along with me from the booklet. And also remember, in the test, you can actually use the formula sheet, okay? So most of geometry problems are going to be plugging in the numbers in the formulas, okay? So, so let's start with problem number 1. There are 12 problems here, so let's start with problem number 1. A factory is painting balls. If the diameter of the ball is 2 inches, how many square inches need to be painted? Okay, so there's a ball, and then it says that the diameter is 2 inches. So this is the ball, 3-dimensional ball. So this diameter is 2 inches. So the radius R is 1 inch. Okay, so whenever you see a problem in circle or sphere, so if they give you the diameter or radius, make sure that you write both. So the diameter is 2 inches and radius is 1 inch. Write both of them down, okay? So now it says how they are painting the ball, so that means that outside surface area, that's what we want, okay? So in all these three-dimensional problems, either you can calculate the surface area or you can calculate the volume. So by reading the problem, you will figure out, so in this case, you want to paint the ball, so that means the surface area, okay? So then you just need to use the formula for the surface area for a sphere. It is 4 pi r squared. 4 pi r squared. So then it's just a simple plug and play, right? Just plug in the right numbers. So 4 pi, radius is 1 inch, so just 1 squared. So it is actually 4 pi square inches, okay? Sometimes in the exam, they will just say 4 pi in the answer. Sometimes they will actually multiply 4 times 3.12, so then you can actually multiply and then 12.48 square inches. Okay? So that's the answer. So you need to make sure that the units are, you got it right? Because it's the surface area. So the area is in terms of square inches. If it's a volume, it'll be in cubic inches, right? So you need to remember the appropriate units. Okay? So these problems are very, very simple, just plug and play kind of problems, okay? So now let's do the second problem. A refrigerator is 28 inches wide, 30 inches deep, 60 inches tall. What is the volume in cubic feet? So you need to read the question very carefully. So all the dimensions are given in terms of inches, and then the volume is asking in terms of cubic feet, okay? So now we know that the volume is the length times width times the height, right? So for this length times width times the height, so the length is 28 inches, and then the width is 30, and then the tall, okay? So now, because these are all in inches, the answer they want in cubic feet, so you need to convert every one of these into feet, okay? So then how do you convert that? So we know that 12 inches equals 1 foot, right? We know that. So 28 inches equals how many feet, right? So in the calculator, you can do that. So you can just do our friend cross multiplication. So then we know that the question mark equals, so 28 times 1, which is 28, divided by 12, okay? So you can do that in the calculator, and then it'll say 2.333, okay? So similarly, you need to do 30 inches converted to feet. So that'll be 30 divided by 12. So that would be 2.5, so this is feet, and 2.5 feet. And then 60 inches divided by 12, that's going to be 5 feet. So the first thing you need to do is convert all the dimensions from inches to feet, okay? So once you do that, then in a formula, it's length times width times the height, just multiplying the 3 dimensions. So now 28 inches is 2.33 feet, and then this 30 inches is actually 2.5 feet, and then 60 inches is 5 feet. So then you just multiply those 3 numbers using your calculator, and then the answer is 29.17 cubic feet. So you need to write that down, the cubic feet, 29.17 cubic feet. So the key thing here was, from inches, you need to convert the dimensions to feet, and then you plug in the feet in the formula, and then you get the answer in terms of the cubic feet, okay? So you need to watch out for the units, whether it's inches or feet, and what do they want in the answer. So you need to carefully look at that, okay? Okay, so that was the volume problem. The next problem, number 3. A ball with 8-inch diameter was filled with air. What is the volume of the air inside the ball? Okay, so you've got a ball. So the ball means it's like a sphere, and then it says diameter 8 inches. So this whole thing, diameter is 8 inches. So D equals 8 inches. So R is exactly half of D, right? You need to remember that. The radius we talked about is exactly half of the diameter, right? So the radius is exactly half, so this part, so that radius is 4 inches, okay? So now it's asking for the volume of the air, so volume of the ball or volume of the sphere, okay? So then the formula, look at the formula sheet, it is 4/3 pi r cubed. So that's the volume of sphere. So now you just need to plug in the numbers. So 4/3 pi, so 4/3 pi, then r is exactly 4, so you plug in 4 in terms of r, right, in place of r, so 4 cubed, okay? So what does this mean? 4/3 and then times pi, 4 times 4 times 4, okay? So you can do it in the calculator, so you can do that. So 4 times 4 times 4, and then times 4, and then over 3, and then times pi, which is 3.14, right? So you can do it in the calculator, it comes out to be 267. So you don't need to waste your time, doing it by hand. 267.95. And it's cubic inches, because this is this dimension, radius is in inches, so your answer is going to be in cubic inches, okay? So let's move on to the next problem, problem number 4. A tourist in a park walked south 100 yards from point A. Then he walked due east for 50 yards to reach point B. If directly walks from B to A, how many yards would he have walked? Okay, so just at the starting point, so from A, okay, so starting point is A, so he's starting here, and then due south, so he's going south means down 100 yards, he's going down, okay? And then he walked due east 50 yards. So then due east means he's going right. So that's 50 yards. Okay. And then to point B. So this is point B. So he walked down 100 yards and then walked across 50 yards. So the question is asking, if you walk directly from B to A, from B to A directly, if he's going this way, how much he would have walked. Okay. So whenever you see this, you see the right triangle, like L and then this. So you know that this is 90 because it's going straight down and then right? So like x-axis, y-axis. So this is 90 degrees we talked about before. So it's a right triangle. So now we want to know what is this, right? So in the right triangle, the side, the longest side, which is opposite of 90 degrees, that's called the hypotenuse. So, right? So we want to get the hypotenuse. So then the Pythagoras theorem, we remember, so a squared plus b squared is c squared, where c is the hypotenuse, okay? So this is a, this is b, and this is c, right? So the Pythagoras theorem says that the hypotenuse squared, c squared, equals this 100 squared plus this 50 squared, okay? So 100 squared you can do in a calculator, and then for 50 squared you can do in the calculator, okay? And then you can add the two up in a calculator, so it's a 12,500, right? So that's c squared, right? The c squared. So then C is square root of 12,500 yards. So you can, so it is, remember, it is not 12,500 over 2. That's not right, right? C squared is 12,500 means that you take the square root of that, okay? So that's very important. So when you take the square root of that, that comes out to be 101.8 yards. So you can directly in the calculator, you put 12,500, that square root button, that's what you want to do, then 111.8. So this is 111.8. So if you go this way and then this way, you walk 150 yards. But then the shortcut, if you can just go directly across, that's going to be 111.8 yards. Okay? So you again need to check for reasonableness. So if you forgot to take the square root, if it says 12,500 yards, it doesn't make sense, right? This is 100 yards, this is 50 yards. How can that be like a 12,000 yards, right? So that doesn't make sense. If you divide by 2, then 6,000 yards. That also doesn't make sense. So if you make a mistake, then you need to check whether does it make sense to me? No. So then what am I doing wrong? So then if you take the square root, then 111 yards. So that makes sense. Okay? So you always need to check your answer before you move on to the next problem. Okay, so let's move on to the next problem, problem number 5. One rectangular box measuring 10 by 8 by 6 inches is stacked on top of another identical box. What is the volume of the two boxes combined? So you got one box on the bottom, and then another box is sitting on top of that, okay? So now they are asking the volume of the combined boxes, okay? So there's one box, so if you look at this one box, so if you look at this two boxes here, so this one box is 10 by 8 by 6. So that means this is the length, this is the width, and then the height, okay? So whenever you have a box, a rectangular box like this, then the volume, the formula, if you look at the formula sheet, it's always length times width times the height. So in this case, it's 10 times 8 times 6. So you can do it in the calculator. It's 480, and these are all in inches, so that's cubic inches. Okay? So this bottom box, the volume is 480 cubic inches. And then the top box also, it's identical box, so it's another 480 cubic inches. So 480 plus 480, okay, so that's going to be, so the total is going to be adding the two numbers up, so it's a 960 cubic inches. So that's a total volume of the two boxes combined. Okay? So this is a straightforward problem. All we have to do is plug in the right number in the formula for the volume. So you need to recognize the shape, you know, what shape are we talking about, and then write down the dimensions, and then use the formula. So next one, problem number 6, a toy is in the shape of a cone. Okay, so then immediately you can draw the picture if you want. So it's a cone, a toy is in the form of a cone, slant height of 5 inches, so this slanting height is 5 inches, circumference 5 inches, so this circumference means this part they are talking about, that circumference, they are calling it 8 pi inches, okay? So what is the total surface area? Okay, so for a cone, the surface area for a cone, if you look at the formula sheet, it is pi r s plus pi r squared, right? So you just look at that. So now the slanting height, so this is s, slanting height. In the formula, you need to know what r is, right? So the radius, you need to know that. But in this problem, they have given only circumference. So the circumference of a circle, if you remember the formula, it's pi d. So in this, they have given, it is 8 pi, or 8, pi times 8. So same thing, right? So the circumference, they have given that to be 8 pi. So then you just plug and play. So if you just look at, compare the two, so d is exactly 8, right? So what this means is that diameter is exactly 8. So that means that, so this is exactly 8 inches. Okay. So then, so what is the radius? Radius is exactly half. So if diameter is 4 inches, radius is 4 inches. So now I've got R, okay? So 5 equals S, and then R equal to 4. So then it's pi, plug in, R equals 4, then S equals 5, right? So pi times 4 times 5, that's what that means. And then pi, then R is 4, 4 squared. 4 squared is 16. 4 times 4 is 16, right? So you can write that as 16. So I've got 4 times 5 is 20, 20 pi, 16 pi, right? So 20 pi plus 16 pi, so that equals 36 pi, okay? So 36 pi, and you can actually, sometimes in the answer, they will give you like a 36 pi, so then you need to check that box, in the answer. Sometimes they do multiply 36 times 3.14, which you can do it in the calculator, and that comes out to be 113.04, and that many square inches. So the surface area of the cone is 103.04 square inches, okay? So here, there's a little twist in this problem. They've given only the circumference. From the circumference, you need to find the diameter. You remember the formula for the circumference, pi d. From that, you compare, and then d is exactly 8, plug it in. Then you get the r, and then you use the surface area formula to get the surface area of the cone, right? So sometimes you have to do one extra step, before you can actually use the formula. Okay, so let's move on to the next problem, problem number 7. What is the volume of this toy? Okay, so the toy that we talked about, the cone. So the volume of the cone is 1/3 pi r squared h, right? So if you look at the formula sheet, 1/3 pi r squared h. And so in this case, 1/3, and then plug in pi, and then the radius r was exactly 4. So 4 squared is actually 16, 4 times 4, right? And then the height is 3 inches. They have given the height as 3 inches, okay? So when the height is 3 inches pi r squared, and then h is 3, okay? So then it is 3 and 3 get canceled, so it's exactly, no, actually, we don't know the height is not given here, so this is not right, okay. So here, the height is not given, so let's go back to the picture. So let's go back here. The slanting is 5, and then we determined the radius was 4, okay. Okay, so now this is h, right? So we don't know what h is. Okay, so we need to figure it out. So, the h, if you want to plug in h, you need to figure out, right? So let's do how do we figure it out? So if the radius is given as 4, slanting height is 5, I want to find this height, okay? So again, you want to go back to the Pythagoras theorem. So this h squared, and then you take the hypotenuse, this is hypotenuse squared, which is 5 squared, which is 25, minus the 1 leg square, so which is 4 squared, 16, so that's actually 9, so h equals 3, right? So you need to actually calculate the height, even though in this problem it's not given, right? So you need to calculate that. Okay. So once you calculate that, then now you can see that 1/3 pi r squared, r is 4, so 4 squared is 16, h is 3, so you figure it out. So it's exactly 16 pi, and that's the answer, 16 pi, and that is in cubic inches. If you want, you can multiply 16 times 3.14, you can do that, and that's the last step, you can do that. So let's see how, if we do 16 times 3.14 in the calculator, it's 50.24. So that many cubic inches, okay? So that'll be the answer. So the one extra step, once you write down the formula, you can plug in the value of R, but you don't know what H. So we have to go back, from this cone, we need to calculate the height using the Pythagoras theorem, okay? So one little extra step we have to do in this problem. Okay, problem number 8. A soup container has a height of 12 centimeters, radius of 5 centimeters. What is the volume? So soup container means that you need to infer that it is actually a cylinder. They don't exactly say here it's a cylinder, but the soup, by looking at the soup can, you need to determine the shape of the soup can is cylinder. And the height, this H, is 12 centimeters. And the radius on the bottom, this is the radius, R equals 5 centimeters, okay? So what is the volume? So the volume of a cylinder is pi R squared H, okay? So that you can get the formula sheet. And then pi, then R is 5 squared times 12, right? So that is pi times 5 squared is 25 times 12. Okay, and that is 300 pi. Okay, so then you can actually plug in the value for a pi, then that comes out to be, so if you put 300 times 3.14, so then that's going to be 942. So 942 exactly cubic centimeters. Okay, so either the answer would be, the answer choice, it will say 300 pi, or it will say 942 cubic centimeters. Okay, so it's a very straightforward problem. The only thing you need to figure out here is that if it's a soup container, then it is a cylindrical shape, cylinder. So you need to know the radius and you need to know the height, and then you can actually plug in the numbers for the volume. Okay. So next one, problem number 9. Okay. So this, a circle is inscribed in a square whose side is 8 inches. What is the area of the circle? Okay. A circle is inscribed in a square. So inscribed means you've got a square, okay, and then a circle is inscribed means like this, okay? So circle is inside, okay? And then now the side of the square, so this side here, they are saying that is 8 inches, okay? So that means that this is 8 inches. So you know that that is the diameter of the circle, okay? So the diameter of the circle is 8 inches. So half of that is radius, so that's the whole thing is 8 inches. This radius R equals 4 inches, right? So R equals 4 inches. So as soon as you see a circle, you want to write down the diameter and the radius, right? So now the question is, what is the area of the circle? So the area of the circle formula is pi R squared, right? So now here it's pi, and then R is 4, so 4 squared, so 4 times 4, 16 pi, and in terms of units, it's a cubic inches, 16 pi cubic inches, so that's the answer. Then if they give in decimals, then you just need to plug in pi equals 3.14 and then use the calculator to multiply, okay? So that here, what you need to understand is that when I have a square, then when I inscribe a circle, so it'll be touching the square like that. So the diameter of the circle is exactly equal to the side of the square, right? So that's what you need to know to do this problem. Okay, so let's move on. So problem number 10. A rectangle is 12 inches by 10 inches from the center of the rectangle, a circle with the diameter 6 is cut out. What is the area of the leftover rectangle? Okay, so it's actually a good idea to draw the picture. So you've got a rectangle 12 inch by 10 inch, right? 12 inches by 10 inch rectangle. In the center, a circle with the diameter 6 is cut out. Okay, so you've got a circle. And so this is 10, and the diameter 6, so this is 6. So this has to be, the circle has to be within this, right? So you need to remember that. So this is 10. Then when you draw the circle with the diameter, so that's 6 inches, that's going to be less than 10. So the circle is going to be inside. It's not inscribed like the previous problem, right? So then, so the diameter is 6. So then the radius exactly half, that's 3 inches. Now they are asking what is the area of the leftover rectangle. So this is cut out. So now they're asking for the area of this leftover, right? So now the area of this full rectangle, so that area, so we know it's L times W. So 12 times 10, so it's 120 square inches. So that's the area of the big rectangle, okay? So now the area of the circle, so the area of the circle is pi r squared, so it's a pi, and then radius is 3, so plug in, so 3 squared, so that's 3 times 3, so that's 9 pi. That's the area of the circle. So the leftover area, so the area that we want, so the leftover area is, we take the full area of the rectangle, which is 120, minus, we remove the circle, which is 9 pi. Okay, you do that. Then you can actually plug in the value 3.144 pi, and then you can put it in the calculator, and that comes out to be 91.74 square inches. Okay? So here, you've got the whole rectangle, so that you know how to calculate the rectangle area. And then you have a circle, you know how to calculate the area of the circle. So when they say leftover, so you have the whole rectangle, then you are taking out the circle, so you subtract that, and then you get the leftover area. Okay? So if you go step by step by step, you just need to do the rectangular area step, and then the circle area step, and then you need to take the difference. That's the last step. Okay? Okay, so now let's move on to the next problem, problem number 11. A right triangle has a base of 4 feet, hypotenuse of 5 feet. What is the area of the triangle? Okay, so they are saying a right triangle like this, and then the base is so right triangle like this, and they are saying the base, so the base, this is 4 feet, and the hypotenuse is 5 feet, and they want the area of the triangle. So the area of the triangle, you know that is 1/2 base times the height, right? So that's the formula for the triangle. So for the base, so you know the base, so this is the base B, so you know that, but you don't know what h is, right? So you need to know the height. So this is the height, right? So this is the height, h. So you don't know what that is, so you need to figure it out. So whenever you see a right triangle and you need to figure out one of those sides, then always you will use the Pythagoras theorem, right? So if you use the Pythagoras theorem, so I want to know h. So what is h? It's always going to be square root of the hypotenuse squared, 5 squared, minus the other leg square, which is 4 squared. Okay? So the square root of 5 squared is 25. 4 squared is 16. So 25 minus 16 square root of 9. Square root of 9 is 3, right? So you need to do this calculation using Pythagoras. You need to figure out what h is. So this h using Pythagoras came out to be 3 feet. So now you go back to this formula for the area of the triangle, 1/2 base is 4, right? 4 feet. Height is 3, so you can plug in all the numbers. Then 2 times 3, that's exactly 6 square feet. So the area, so if you calculate the area of the triangle, that's 6 square feet. Okay? So that's what we talked about before. If you have like a 1 square foot tile, 6 of them you can fit in there. Okay? So since it's not like a square or a rectangle, you may have to cut the tiles into pieces, but it's exactly, you will need 6 tiles, each 1 square foot, to fill this triangle. That's what that means, right? Okay, so here we had to do one extra step, use the Pythagoras theorem to get the height, and then we could actually use the formula of the triangle area. So the last problem, problem number 12, it says that in this figure, so there is a figure here, so let's put the figure here. We've got the figure, and then this is A, this is M. So it says that in this figure, the line A, line M are parallel, okay? And the measure of angle, so there's a number 2, so this measure of this angle is 60 degrees. And then they're asking, what is the measure of 8, which is this? What is the measure of this, they are asking, okay? So now you need to remember, so when we have 2 parallel lines, and then we've got a transversal, then we know that, this angle is exactly equal to this angle. So corresponding angles are equal, right? We said that. So that angle is exactly that angle. So now we want to find out what this angle is. So now another thing we learned, so this is a straight line, right? Straight line. And this is a line here, and that's 60. So whenever you have a straight line, then that whole thing is straight angle, 180 degrees, right? So straight angle is always 180. And this part is 60, so this part is going to be what? It's 180, so this part is going to be 180 minus 60, so it's going to be exactly 120 degrees, okay? So these problems are very easy. All you need to figure out is that these 2 corresponding angles are equal, right? So then you need to know that this is a straight angle, so that whole thing is 180. So if this is 60, this is going to be 180 minus 60, that's 120, okay? So with this, we have covered step 5. So in step 6, we will do actual practice test, okay?